In Chapter 2, Web Application and Database Security, Core Defense Mechanism, you might head on to your e-learning and PowerPoint presentation of Chapter 2 is available, and including also the summary of our Chapter 2 handouts can be downloaded in PDF format. Core defense mechanism, the fundamental security problem with web application that all users input and untrusted. It gives rise to a number of security mechanisms that applications use to defend themselves against attack. So sometimes it's virtually all application employs mechanisms that are conceptually similar, although the details of the design and effectiveness of implementation differ from wide indeed. At the end of this module, the students will be able to know how to handle the user's access, know how to handle users' inputs, and know how to handle attacks. The defense mechanism employed by web application compromises the following core elements. In handling users' access, centrally security requirements that virtually any application needs to meet is to control users' access to its data and functionalities. In a typical situation, there are several different categories of user. For example, anonymous users, ordinary authenticated users, and administrative users. Further, in many situations, different users are permitted to access a different set of data. For example, users of webmail applications should be able to read their own email but not other people. Most applications handle access using a trio of interrelated security mechanisms. That is authentication, session management, and access control. In authentication, mechanisms logically the most basic dependencies in an application handling of the user's access. Authenticating a user involves establishing that the user is in fact who he claimed to be. Without this facility, the application would be need to treat all users as anonymous. So this is kind of at the lowest possible level of trust. In session management, this is the next logical task in the process of handling users and accessing to manage the authenticated user sessions. After successfully logging into the application, the user will access various pages and functions, making a series of HTTP requests from the browser. At the same time, the application will be receiving countless of other requests from different users, some of whom are authenticated and some of whom are anonymous. In order to enforce effective access control, the application needs a way of identifying and processing the series of requests that originated from each unique user. In access control, this is the final step in the process of handling users' access, is to make and enforce correct decision regarding whether each individual requested should be permitted or denied. The proceedings of mechanism are functional correctly and application knows identity of each user from whom each request is received. On this basis, needs to decide whether that user is authorized to perform the action or other data that he is requesting. So this is like an access denial. The message will appear from the browser. Second core defense mechanism is handling users' inputs. Recall the fundamental security problem described in Chapter 1. All users' input is entrusted. A huge variety of different attacks against web application involving submitting unexpected inputs, crafted to cause behavior that was intended by the application designers. Correspondingly, a key requirement for application security defense is the handling users' input. It should be safe manner. So this input-based vulnerability can arise anywhere within application functions. These are some varieties of inputs. You can see that performing an input validations might approach to your input handling. There are various broad approaches that are commonly taken to the problem of handling users' inputs. Different approaches are often preferably for different situations and different types of inputs. And a combination of approaches may sometimes be desirable. First is reject known bad. In general, it's regarded as the least effective approach of validating users' input for two main reasons. First, a typical vulnerability in a web application can be exploited using a wide variety of different inputs, which may be encoded or represented in various different ways. Except known good. This approach employs a whitelist containing a set of literal things. Patterns that set the criteria, it's known to match only the benign input. Validation mechanism allows data that matches the whitelist. By the way, the reject known bad, this approach employs a blacklist containing a set of literals. This kind of pattern that are known to be used in the attack. So this validation mechanism blocks any data that matches the blacklist and allows everything else. Sanitization. This approach is based on highly effective. In many situations, they can be relied upon a general solution to the problem of malicious inputs. For example, the usual defense against cross-site scripting attacks is to HTML encode dangerous characters before these are embedded into a page of application. So this approach we recognize sometimes that we cannot guarantee a safe. Instead, rejecting these inputs, an application sanitizes its various ways to prevent its having any adverse effect. So basically, some people are trying to remove some temporary visited websites, temporary save, cookies, and so on. In safe handling, we have many web applications vulnerabilities that arises. Suppose supply data is being processed in the usual way. It's often that the case of vulnerabilities can be avoided not by validating the input itself, but by ensuring the processing that is performed on inherently safe. In some situations, there are safe programming methods available that avoids common problem. As for example, SQL injection attacks can be prevented through the correct use of parameterized queries for database access. In semantic checks, this kind of defense described as far as addresses the needs of defend the application against various kinds of malformed data whose content has been crafted to interfere with application processing. But however, with some vulnerabilities, the input supplied by the attackers is identical to the input that an arbitrary, non-malicious user may submit. Thus, core defense mechanism is handling attackers. We will discuss the handling errors, maintaining audit logs, alerting administrators, and reacting to the attacks. In handling errors, however, this carefully and application developers that are validating users' input. It is virtually inevitable that some anticipated error will occur. Sometimes the error resulting from the action of ordinary users are likely to be identified during the functionality and the user's acceptance testing. Maintaining the audit logs is also considered a primary, like a value of investigating the intrusion. So, which means following such incidents might occur, effective audit logs should enable the application owners to understand exactly what has taken place. In any application for which security is important, key events should be logged as a matter of course, in any matter of course, and at the minimum, this typically includes all events relating authentications, key transactions, except attempts and requests. In alerting administrators, audit enables an application owner to retrospectively investigate intrusion attempts, and it's kind of possible if we take legal action against the perpetrator. However, in many situations, this is desirable to take much more immediate action in real time. In response to attempted attacks, for example, the administrator may block the IP address or the user account being used by the attacker. So in extremely case, they may even take the application offline while the attack is investigated. Reacting to attacks. In addition to alerting the administrator, many security critical applications are built into mechanism to react defensively to users who are identified as potential malicious. The last one is for managing the application. In many applications, administrative functions are implemented within the application itself, accessible through the same website interface or its some core non-security functionality. Any useful application may need to manage as administered, and this facility often forms a key part of application security mechanism, providing a way for administrators. Thank you very much, and we'll see you to the next chapter.